This will be our last problem-solving technique that we highlight in this class, although there's certainly more, and you can find varieties of all of these in many curriculums. So this last one is called use a variable. It sounds very algebraic. Well, it is very algebraic. So this is a contrived problem, of course, but these patterns can be very interesting ways to think about how to write algebraic expressions, how to make sense of something, how to write a number sentence. So let's take a look at it. A local coffee shop hosted a coffee cup stacking contest. Leanne noticed a pattern. And you're thinking, well, okay, great job, Leanne. Do I notice a pattern? She told the judges that figure 100 would have 203 coffee cups stacked up. Was she correct? Use mathematics to prove or disprove Leanne's claim. Now, you don't have to use a variable to solve this problem. You can break it down in a variety of other ways. How would you use a variable? Well, a variable would require to be able to write some sort of algebraic expression. You have to notice something, though, to do that. And there's many ways you can notice that. And with patterns like this, visual patterns, by the way, there's a great website, visualpatterns.org or .com. I don't know, you can look that up. That has a bunch of these. So you have to notice something about this pattern. What do you notice? Well, you might notice that it's getting taller by 1 each time. So maybe you notice like figure 1 has a stack of 2 and it has 1 on top. And then it has 2 stacks of 2 and 1 on top. And then it has 3 stacks of 2 and 1 on top. So if you were to think about figure 4, if you were to draw it out for a second, because this is one of the strategies, you might think, well, that would have 1, 2, 3, 4, and 1, right? There'd be, I'm just drawing little blobs for coffee cups. There'd be 4 stacks of 2 and 1 on top. And so using a variable might be something like this. Well, what would figure X have? Now that's kind of strange at first, but what it's asking you to do is relate the number to what you're seeing in the diagram. Okay, well, notice that in figure 4, right, there was 4 stacks of 2. In figure 3, there was 3 stacks of 2. In figure 2, there was 2 stacks of 2. In figure 1, there's 1 stack of 2. So that must mean that in figure X, there would be X stacks of 2. Now, how do I draw X stacks? I can't really draw it. So I'm just going to put like dot, 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 like use your imagination. There's some number of stacks. I don't know how many stacks. So I'm just going to say there's X stacks of 2, but then we always have 1 more coffee cup on top. All right, now how do we write a variable or expression for that? Well, we might think about how we would write expressions for the ones with the numbers first. Like how could you count efficiently the ones in figure 4? Well, you have 2 times 4 plus 1. Where did you get that? Well, you have 2, and then you have 4 stacks or 4 rows of 2. So 2 is the number of coffee cups in those little ovals that I drew, and 4 is the number of stacks. In figure 3, you might notice that it's 2 coffee cups in each row times 3 rows plus 1. In figure 2, you might notice it's 2 coffee cups in each row times 2 plus 1. And that would actually work here. It's 2 times 1 plus 1. And so you can notice that each one of these is 2 times something. The something is the figure number plus 1 more. Aha, there we go. I have my variable expression. So now I can use that to think about. Now remember, there was a question here somewhere, right? We've got to go back to the question. What was it? Well, it was Leanne. Was she right or wrong? She told the judges that figure 100 would have 203. Was she correct? Well, we could use our variable expression to think about it. If we know figure X is represented that way, then figure 100, right? We don't have to draw it, right? Would be found out by doing 2 times 100 rows or stacks, right? Plus 1 more, and that would give me 201. In other words, I'm just using this expression and plugging in the number 100 for it. So using a variable, I think that Leanne's close, but not correct. And you can use a variable or an algebraic expression to find many things when there's patterns, especially. I hope this is helpful.